Welcome back, everybody, for another deep dive. This time we're tackling AI, large language models, specifically
LLMs.
LLMs. Yeah, you got it. I bet you've interacted with them without even knowing it.
Yeah, it's pretty likely at this point.
Yeah, they're the brains behind a lot of things like chatbots,
That's right.
AI writing assistants, even those crazy realistic deepfakes.
It's amazing how those things work, right? To be able to understand and generate text like a person.
Yeah, almost like they're thinking for themselves, but there's a catch, right?
There is.
These models, they're absolutely huge.
They are massive.
They need a ton of computing power.
Yeah, you need a lot of memory.
And that gets expensive.
And it uses a lot of energy too, which isn't good.
Yeah, not very environmentally friendly.
Right.
So our deep dive today is all about a research paper describing a new technique called BitNet a4.8. A4.8, which aims to make these LLMs smaller, more efficient, without losing their smarts.
Right, so making these powerful AI tools more accessible,
Yeah.
more sustainable.
Yeah. Okay, let's get into the details.
Sounds good.
The paper focuses on making LLMs more efficient, and BitNet a4.8 seems to be the key innovation here. But before we get into a4.8, can you give us a little background on its predecessor, BitNet b1.58?
Absolutely. B1.58 was a really big step forward in this whole field.
Yeah.
It used a technique called one-bit quantization to shrink the model size.
One-bit quantization.
Yeah, so imagine you have a picture,
Okay.
a high-resolution picture with millions of colors.
Okay.
One-bit quantization is like reducing that picture to black and white.
Oh, okay.
So you're using less information to represent the same image.
Yeah, okay.
That's essentially what they did with the model's data.
Yeah, okay.
Making it much, much smaller.
So they were already working on streamlining these LLMs. How does a4.8 build on that?
Well, A4.8 uses a combination of 4-bit activation and sparsification.
Okay, 4-bit activation.
Yeah, so think of it like a dimmer switch.
Okay.
But instead of having that smooth range of brightness, it only has a few preset levels. That's what they're doing with the signals inside the model, representing them with fewer bits to make it more compact.
So it's like giving the model a more limited but efficient language to work with?
Exactly. And then there's sparsification.
Okay.
So picture like a giant web with some connections stronger than others. Sparsification is like pruning that web, getting rid of the weaker connections to make it leaner and more efficient.
So it's like cleaning out your closet, getting rid of things you don't really use.
That's a great way to put it.
But why are some parts of the model easier to prune than others?
Good question. That's because different parts of the model have different sensitivities to being shrunk down.
Okay.
It's like thinking about different internet needs in a city.
Okay.
Some areas like financial districts,
Yeah.
they need super fast connections to handle tons of data.
Yeah, makes sense.
Other areas, maybe residential neighborhoods, might be fine with slower speeds.
Okay.
So BitNet A4.8 is like a smart city planner,
Right.
allocating that data bandwidth where it's most needed.
So it's about strategically distributing resources within the model.
Exactly.
That's pretty clever.
Yeah, the researchers were really thinking there.
But does this actually work in practice?
Well, they put it through its paces.
Oh, really?
Yeah, the research team compared it to the older model
Yeah.
and even traditional larger LLMs.
Oh.
And the results are pretty impressive.
Okay, I'm hooked. What did they find?
Well, first they found that A4.8 performed just as well as the older model and the standard LLMs on all sorts of different language tasks.
So no sacrificing performance for efficiency.
Nope, not at all.
That's amazing. So we're getting the same intelligence in a smaller package. What else?
Well, remember how we talked about sparsification?
Yeah.
They found that BitNet A4.8 was incredibly efficient at pruning those weaker connections.
Okay.
In fact, in the 7 billion parameter model, it was only using about 3.4 billion parameters.
Wow.
Imagine cutting the model almost in half without losing performance.
That's huge. But what does this actually mean for people who aren't AI experts? How could this impact our daily lives?
Well, imagine having an AI assistant on your phone that can do amazing things, like translate languages or write different kinds of creative content, all without draining your battery in minutes.
Okay. Yeah.
Or think about researchers in fields like medicine or climate science who could use these powerful models on less powerful computers.
Yeah.
That's the kind of potential we're talking about.
It sounds like this could truly democratize access to AI, making it more accessible and sustainable for everyone.
Absolutely. But that's not all. There's another interesting aspect of BitNet A4.8, and that's its compatibility with something called low-bit attention.
Okay, now you've got me curious. What's low-bit attention all about?
Well, think of it this way. Imagine you need to summarize a really long article.
Okay.
Instead of reading every single word, you probably skim through it, picking out the key points and main ideas. That's kind of what low bit attention does. It gives the model a super efficient way to process large chunks of text without getting bogged down in the details.
So it's like giving the model speed reading superpowers.
Exactly. And this is crucial for tasks like translation or summarization, where the model needs to quickly grasp the meaning of a whole lot of text.
So BitNet a4.8 is not just smaller and more efficient, it's a speed reader too. This is blowing my mind, but what's the big picture here? Where does all of this lead?
That's a great question. And I think the biggest takeaway is that this type of research is opening up some incredible possibilities for the future of AI.
All right, take it away. What are some of those possibilities?
Well, for one, smaller, more efficient models mean AI could be used by a wider range of people and organizations, even those without access to supercomputers. It also means less energy consumption, which is great news for the environment. And perhaps most excitingly, this research could pave the way for even more innovative techniques in the future.
It sounds like we're on the cusp of a major shift in the AI landscape.
It certainly feels that way, and that's what we'll be exploring further in the next part of our deep dive. Stay tuned. Welcome back to our deep dive into BitNet a4.8.
Still amazed by all the potential benefits we talked about. It sounds like BitNet a4.8 could really be a game changer.
Yeah, potentially, definitely.
In terms of making AI more accessible and sustainable for everybody.
It could definitely shake things up.
Yeah.
It's really fascinating to think about this research, like in the whole context of LLM development. For years, researchers have been trying to make these models more and more powerful.
Right.
But without them becoming like total energy hogs.
Yeah, it's like a constant balancing act.
Exactly.
Between like intelligence and efficiency.
Yeah, air LLMs and traditional LLMs, while incredibly capable, could be, expensive to run, not very environmentally friendly.
Yeah.
And that really limited, who could use them and what they could be used for.
So researchers have basically been on this quest to find that sweet spot.
Yeah, like all the smarts.
Yeah.
In a smaller, more sustainable package.
Yeah, exactly. Have your cake and eat it too.
Exactly.
But how does BitNet a4.8's approach compare to other things that researchers have been exploring?
That's a great question. One common approach is something called pruning.
Pruning.
Yeah. It's similar to the sparsification we talked about earlier.
Yeah.
Essentially removing less important connections in the model.
Okay.
To make it leaner. You can think of it like decluttering your computer's hard drive. Deleting files you don't need anymore.
So it's all about trimming the fat, getting rid of the excess baggage.
You got it.
What other techniques are out there?
Another interesting one is knowledge distillation.
Okay.
This involves training a smaller, simpler model to basically mimic the behavior of a larger, more complex one.
So it's like an apprentice learning from a master.
Exactly. They absorb the essential knowledge and skills.
Right.
Without having to learn every single detail.
So it's about transferring the essence of the expertise without all the extra complexity.
Precisely. And then, of course, there's quantization.
Right.
Which we've already talked about.
With 4-bit.
Yeah, with a4.8's use of 4-bit activation.
Yeah.
This technique involves using fewer bits to represent the model's data. Essentially compressing the information without losing too much detail.
So it's like finding a more efficient way to pack a suitcase, getting everything you need in.
Exactly.
Without overstuffing it.
Exactly. What makes BitNet a4.8 so exciting is that it combines these different techniques in a novel and effective way by strategically employing 4-bit activation and sparsification. It achieves both compression and efficiency without compromising the model's performance.
So it sounds like they really hit the jackpot with this approach.
It really does. It seems like it.
Yeah, we talked about 4-bit activation earlier, but I'm curious, how does that shift from the previous model's 1-bit quantization really make a difference?
It's a crucial step forward. Remember the dimmer switch analogy we used?
Yeah.
Moving from 1-bit to 4-bit activation is like having more levels on that dimmer switch, allowing for finer control over the model's signals.
Okay.
It's like having a more nuanced way of expressing those signals, which leads to better performance.
So it's like giving the model a richer vocabulary to work with.
Exactly.
Leading to more sophisticated outputs.
Exactly. And this has a direct impact on how well the model can handle complex language tasks with 4-bit activation. BitNet a4.8 can capture more subtle variations in language, which improves its ability to generate text, translate languages, and even write code.
Wow, it's amazing how, a seemingly small change in the number of bits can have such a big impact on the model's capabilities.
It really is. It highlights just how much progress is being made in optimizing these models, and the benefits go beyond just accuracy, too. The increased precision from 4-bit activation also helps the model adapt to new tasks and data sets. A model that understands nuances in language is better equipped to learn new things quickly.
So it's not just about being smart, it's about being a quick learner as well.
Exactly.
That's incredible. But let's shift gears for a moment and talk about the practical implications of this research. How could BitNet a4.8 impact our everyday lives?
Well, the possibilities are pretty exciting. Imagine a world where AI assistants are seamlessly integrated into all our devices, providing personalized help without draining our batteries or using up all our data.
Yeah, it's like having a super intelligent sidekick who's always there to lend a helping hand.
Exactly.
What other applications can you envision?
Think about education. Smaller and more efficient LLMs could personalize learning experiences, adapting to each student's needs and learning styles.
It's like having a customized tutor like right in your pocket.
Exactly. Ready to help you whenever you need it.
That would be revolutionary for students. What about the impact on research and development?
That's another area where BitNet a4.8 could be a total game changer by making AI more accessible to researchers. We could accelerate innovation in fields like medicine, climate science, art design. I mean, the potential is truly vast.
It sounds like this technology could have a ripple effect across countless industries and aspects of our lives. I'm curious, though, with all this talk about AI becoming more powerful and accessible, are there any things we should be cautious about?
That's a really important question, and one that we'll definitely delve into in the final part of our deep dive. Stay tuned.
And we're back for the final part of our deep dive into BitNet a4.8.
It's been quite a journey so far.
Yeah, we've covered a lot, from like how it works to all the amazing things it could do.
Right, all the potential benefits.
Like making AI more accessible.
Yeah, to more people.
To researchers, developers.
Breakthroughs in all kinds of fields.
Yeah, and even like how we interact with technology day to day.
Exactly. But as with any powerful technology,
right,
it's really important to think about
the implications.
Yeah, all the implications.
Yeah, so as we wrap up our exploration of a4.8, what are some things we should be thinking about as this technology keeps developing?
Well, one thing that immediately comes to mind is responsible development.
Okay.
As AI becomes more sophisticated, it's super crucial that researchers and developers really prioritize safety and ethical considerations.
Yeah, it's like building a powerful engine,
Yeah.
You got to make sure it has all the right safeguards.
You got to make sure it's not going to explode.
Yeah, before you fire it up.
Exactly. We need to make sure that AI is developed and used in a way that benefits humanity as a whole.
That makes sense. What are some other things we should be mindful of as AI becomes more integrated into our lives?
Well, one thing that comes up a lot is the impact on jobs.
Right.
As AI becomes more capable of performing certain tasks, some people worry that it could lead to, job displacement.
Yeah, that's a valid concern.
It is.
But AI can also create new opportunities.
Exactly.
And enhance existing jobs.
It's not about replacing humans.
Right.
It's about augmenting our abilities and freeing us up to focus on, more creative and fulfilling work.
So it's about humans and AI working together.
Exactly.
Each leveraging their own unique strengths.
Exactly. And I think that's where the real excitement lies. AI has the potential to help us solve some of the world's biggest problems.
Yeah.
Like tackling climate change.
Right.
Developing new treatments for diseases.
It's about using this technology to make the world a better place.
Absolutely. And to do that, we need to have those open and honest conversations about the future of AI. Involve experts from different fields and engage the public in these discussions.
So it's about working together to shape the future of AI in a way that benefits everyone.
Exactly. It's been a fascinating exploration of BitNet a4.8 and its potential to really transform AI as we know it.
It really has been. So as we wrap things up, what's the one key takeaway you want our listeners to remember from this episode?
I think the most important thing to remember is that AI is a tool. And like any tool, it can be used for good or for bad.
Right.
It's up to us to guide its development and make sure that it's used responsibly and ethically.
Powerful message. So as we conclude our deep dive into BitNet a4.8, let's leave our listeners with a final thought. As AI continues to evolve, what role will you play in shaping its future? Thanks for joining us on this incredible journey. Until next time, stay curious, stay informed, and stay engaged in the exciting world of AI.
Until next time.